Good morning. Good morning.
Good morning.
Once we get through with this presentation, you'll understand why I'm trying to raise your energy level a little bit, right? Okay, the other thing is I've given Dimitri on this laptop a PDF with my notes on this presentation. And before I get started, I just want to add something to what Bill just said about as renewables come on board, maybe we'll move to a focus more on people and not be worried quite so much about energy. I was at the American Council of Engineering Companies Conference in Washington, D.C. this week, and on Monday afternoon we had a keynote speaker, a gentleman, Salim Ismail, who has worked with Google. He was the innovation director at Yahoo, and he made the speculation based on Moore's law and the doubling effects and looking at technologies since the beginning of the Industrial Revolution, and given where we are with solar today and battery technology, that in 12 years we will have deployed enough solar to meet the energy needs of the entire world. And then 5 years later, our batteries will catch up, and we will have deployed storage capable of utilizing all of that energy. So I think that's a promising thing, and it comes from a fairly knowledgeable person on the technology side. So let's get started. We're going to talk about a framework for building health. You're going to hear some overlap with Bill's presentation, but probably said in a different way and probably a lot less technical. We'll talk about the research and impacts of toxins in buildings, and some of that came out of some of the same studies Bill talked about. Ventilation, lighting and daylighting, comfort and productivity, and then looking forward. So this is beginning to integrate some of the other variables other than ventilation and looking at the whole building and how it impacts the person. So one thing we might, a lot of this came out of a study done, some of the studies done at the Harvard T.H. Chan School of Public Health, and this was in a recent publication. We'll talk about it. This makes a bold statement that the people who are responsible for the design and construction and operation of your buildings are probably just as important to you as your primary health care provider. And that's just because of you're looking at health and wellness in general. We all know that a big part of it's our lifestyle, right? Our behaviors, how we eat, drink, sleep, those kind of things. Genetics makes up some of it, but then here, our environment, and you heard about that a little in the last presentation, and access to health care. And most of the world now is becoming to where they have access to health care. Something that Bill said, and this is just said a little differently, you know, the cost of designing, operating, and building a building over the life cycle of a building is about 10%. Our big cost, and if we can save small portions of it by increasing productivity and keeping people healthier, 90% of the life cycle cost of owning and operating a building and the people in it are the people. And that's important. So part of that study I talked about with the T.H. Chan School got converted into something called the 9 foundations of a healthy building, okay? And if you look at these things and look around that circle, air quality, thermal health, moisture, dust and pets, safety and security, water quality, noise, lighting and views, and ventilation. I mean, how many of those things does FASHRAE not touch on in one of our standards, our handbooks? I mean, we cover the gamut. I mean, that is FASHRAE for the most part. Even now with security, I mean, a lot of focus again with Sheila's theme on our energy future and cyber security and what that has to do with and how to protect our energy grids and those things. But the big ones, we'll see some more about each of these as we go through the presentation. So building on that framework, I'm going to start a little bit with toxins. Bill talked a little bit about those. And most of us assume, I mean, especially in the U.S., you know, we've got really good regulatory, or we've got lots of regulations, whether they're good or not to be debated. But most people assume that the chemicals in a building have been tested and approved for safe on humans, right? And that's probably not true. This isn't going to be a big doom and gloom presentation, but here's why materials matter. All right, 80,000 chemicals used in manufacturing today with minimal regulation or oversight. All right, 85% of those chemicals in use today have no health data associated with them. We just don't know. You know, I mean, we don't know what we're doing to ourselves. All chemicals aren't bad, of course, okay? They've done some pretty nice things for us. Otherwise, we wouldn't be moving towards 7 billion people on the planet. We're flourishing. 67% have no data at all. And you can see here some man-made chemicals tested for safety. You know, 80,000, ones tested for safety, 300. Chemicals with enforceable regulations, 20. That doesn't make a blip on the radar when you start looking at 80,000 chemicals, right? But there are 6 classes that at least most of the research has determined are things that we need to avoid, beginning to show up on things called red lists for chemicals, right? Highly fluorinated materials that go into a lot of things like Vortex and the things you put in rain jackets and stuff we put on our bodies. Antimicrobials for various reasons. You know, the soap that's antimicrobial. I mean, one of the reasons that's not particularly good is it begins to create bacteria that's resistant, highly resistant, and then we have a hard time curing any diseases that we get from those more resistant strains of bacteria. Flame retardants, and we'll talk a little more about that in a minute. And then these bisphenols and phthalates that go into plastics that we drink. You know, I mean, it's amazing now that, you know, bottled water is the biggest products of the Coca-Colas and the Pepsi-Colas. I mean, they've made a fortune and found out they don't have to flavor it so much and can make more money. Some solvents, VOCs, and then certain metals like leads and mercury and those kind of things. So many of the common building materials, an assessment of 102 of the commonly used building materials and products found 86% contain chemicals that are toxic to mammals, okay? And then when we look at toxins that get into our body or that are in our body right now, if you want to look, mercury, if you test the population, now this is U.S. children, but I mean, we're older, so more than likely we're definitely infected with these things, or we've ingested these things. But 89% of the children in the U.S. right now, when tested, test positive for mercury in their bloodstream. 100% for lead. Other pesticides, 83%. PCBs have been outlawed since the 70s, 100%. BPA and PB. This is the plastics. This goes into all the plastic bottles, and then this is those fire retardants I talked about, 100%. So I mean, you see it in you know, different news and studies almost every day. If you go into the research or look at some of the newspapers, that exposures to these things, flame retardant chemicals, can increase thyroid problems. The bisphenols that go into plastics, you know, impairs double-strand break repair machinery, and you know, you can dig into that research to understand what that sentence means. But this one, associations of cognitive function scores with carbon dioxide, ventilation, and volatile organic compounds. Now, Bill, when you talked, you said there were a couple of studies that looked at CO2. This is one that was done actually at University of Syracuse, but they used, I think they used Harvard's quality control process, because John Spangler's on the team too, I see him up there. But they did just the same thing you just mentioned. They took 24 people, they set them up in 2 separate offices with identical cubicles. They were professional grade people, so people working at a professional level. And I'll tell a little bit more about that later, but that was a double-blinded control study using ventilation rates and CO2 concentrations and how it affected our cognitive abilities. But let's see, so playing with fire. I mean, there's been a lot of study now that there is no evidence that flame retardants in home furniture, baby products, and some other consumer products improve fire safety. It was until a few years ago the law that everything had to have a fire retardant, a foam-based piece of furniture had to have fire retardant. Our state Office of Education, or K through 12 schools, still will not allow a non-flame retardant piece of furniture go into a K through 12 school, even with this mounting bit of information. And one real easy way to look at it is flip the piece of furniture over and look at the tag. But now in the U.S. it is allowed that you can buy furniture without it. It's very easy to get the same flame retardant rating with just the cover that's on the foam. So some of these flame retardants. Biggest reason we outlawed it or outlawed it, it used to be on every bit of a baby's pajamas and clothes like that, especially, so we're just putting them in a sack and putting them to bed with it, so they got to sleep with it, right? So, some of the easy ways, again, like I said, I'm not going to get into the weeds, but some of the easiest ways for us to deal with eliminating ingesting these things and getting exposure to this is just washing our hands, trying to keep our hands out of our mouth. But how do we get it? How does it get there on our hands in the first place? Well, we talked about ventilation and filtration in the last presentation. And with poor filtration, it's on the dust. It's on the surface of everything we touch, right? And so all you got to do when you've been walking around an office building or this building or anything and you've been touching things like this is just simply when you go to the restroom, rinse your hands off, right? It's one way, a simple way to break that pathway that gets it into your body and helps you ingest it and then helps your organs then absorb it where it becomes dangerous to us. Some other ways, again, like we've said, Technical Bulletin 117/2003, not sure if that's by the NFPA, or whoever allows that you can comply with the flame retardant nature of a piece of furniture without actually adding a chemical flame retardant to it. And most labels, at least in the U.S., will tell you now whether your upholstery does or does not have it when you buy a piece of new furniture. So the other thing we can do is we can choose materials. There's a site called Home Free. It's a public resource that translates some of the research into simple guidance on how to buy and build building materials. And a lot of architects, a lot of residential products there, but the emphasis on finding products that avoid some of those 6 categories of chemicals that I mentioned before at little or no cost premium as well. So I'm running through this a little quickly, but just trying to keep us on schedule. So let's move to ventilation. I'll try not to repeat things too much more than what Bill's already talked about. Again, a lot of study, a summary of some of the respiratory illness studies that have been going on. Army recruits, students, and office workers have been 3 studies. 33 to 41% less respiratory illness and 15% less absences with better ventilation. More space per occupant, so giving people a little more space. So that can be looked at in two ways. You know, one, there's separation there from a standpoint of spreading colds and stuff like that, but also you've got more volume there, so essentially a greater rate of ventilation per person. And looking at that, more ventilation and more space, 49 to 70%, 76% less flu and respiratory illness. UV radiation, Navy recruits 23% less respiratory illness. Air-conditioned versus non-air conditioned building. Again, the populations were armed forces troops, 16 to 27% less cold symptoms. Mold versus no mold in residences, and this is apartment dwellers, 54% less respiratory illness. And mold is one of those things that can be caused by poor envelopes and poor operations and maintenance, right? So again, that's an operations issue as much as anything. Bill talked about the same study. In fact, I think maybe these same slides here were looking at CO2, part of that study that we mentioned, and it was published in the Environmental Health Perspectives in December of 2012. Bill gave the same ranges, 1,000 to 2,500. And this study, I believe, ends up recommending that we should be going to a maximum design condition of about 800 parts per million in the building. That significantly does increase our ventilation rates. And you can see their cognitive scores on standardized tests at the different rates. So at 2,500, a significant effect. At 1,000, the scores got better, and then reducing the ventilation, which will get up to that 50 liters per second, 30 to 50 liters per second Bill was talking about. You get much better scores or much better performance. And it stands to reason. I don't know, we talk about collaborative and multidisciplinary, and we should start looking at some of the things our psychologists do when they're studying people. When they got a test chamber and they want to induce stress on a person, increase their heart rate and those kind of things, they enrich the atmosphere with CO2. So that's the way for them to just induce a stressful situation on a person in a laboratory. This next one's just going to be kind of a little study. Young man in my office that actually was at Harvard and participated in those studies as a participant. He was a subject. He's gotten kind of nerdy. He's putting VOCs and CO2 sensors in his house there in Charleston. He works for me. It's funny. He came in the other day and he told me, he said, "Do you know that cooking Thanksgiving dinner, CO2 ppm in the house hit 5,000 parts per million?" And then he started going on about his PM2, but I said, "Well, but Joel, that was, maybe an hour." So he's got these sensors and they report back at his desk, so sometimes I'll walk in there and he's looking at these graphs when he's supposed to be doing something else. And then he says, look in my living room, look how many hours I'm there that I'm really impaired. And I just, it's kind of funny to listen to him talk about it, but that didn't bleed out enough for you to see. But he gets really concerned that his cognitive functions are impaired in his living room and bedroom. But he's just trying to make a point, and he's doing a good job of it. And he's passionate about what we do on a day-to-day basis. So, some other lessons learned from sensors. This is another funny Joel story. Like I said, he's gotten into this a little bit. So this is his dashboard that comes up on his desk. You can see the total VOCs that's in red, his humidity and things like that. But he got a call. He got an alarm popped up on his phone not too long ago, okay? And he immediately picks up the phone and calls his wife or his fiance at the house, you know, and he said, what's going on? Why's the VOC's gone through the roof there at the house? You know, damn diffuser. He knew immediately when she plugged in a new vaporizer that vaporizes these lavender scents or something like that, one of those oil vaporizers. So who knows if that's good or bad for us or not. Some VOCs aren't bad, but I think it's just kind of funny to watch him go through working through these things. So let's switch from this then to, again, some easy things to make a difference. And I guess the jury's still out, but plants, NASA's done a lot of study. In fact, most of the research, that's probably, yeah, it's a NASA study here, Bill Wolverton, and the Department of Industry on plants, and especially for the space station and things like that. So we've got these plants around, and they've studied which plants are good at filtering out certain things. But you'll notice most of them, there's a common thing: benzene, formaldehyde, xylene, a lot of the VOC stuff. Okay, so plants are really good at that. And like I said, you got to think Joel has got a phobia, but that's his desk. Okay, and if he could, it would just be a wall around him, you know, and we'd have to wade through it to get to it, but it's fun. The other thing is we live in a building, we work in a building that was built in the 1840s, okay, so we can almost see through the walls in most places. I got a CO2 sensor sits behind my desk, and it barely ever gets about 100 parts per million above ambient outside, so about 440 outside. Our office has got an exchange rate of about 1 a minute, I think. It may get up to 550. So again, some other stuff. Just open a window. Bill mentioned the passive benefits of most residents don't have, you know, ventilation systems that bring in outdoor air. Commercial buildings are likely to have ventilation built into it, but a home monitor like created that dashboard there and can look at the things in your house are starting to come down. They're about $100 to $300 now. But the other thing is the, I guess, physiology of breathing good air. And I'm not saying polluted air, but we're finding we've got this, again, medicine, we're starting to learn a lot of stuff about medicine in this multidisciplinary thing. We've got this gut biome. We've got these microbes that live inside us. And there's more of them than there are cells in our body that live in us. And our survival depends on what they do. And believe it or not, some of the things they need to eat to stay healthy are found in outdoor air. And sometimes just getting out, taking a walk, getting some fresh air can do really good for us, because those microorganisms release what's called neurotransmitters, and they go straight to the brain, and they can change your mood. And I'm going to tell you a little hypothetical story at the end. Don't let me forget before the last slide. So let's move on from ventilation, which we know now is good for us. Increased ventilation, and hopefully at some point we will get that energy is not the reason we're making, energy cost is not the reason we're using to make ventilation decisions. And hopefully our energy supplies can get to the point we don't have to do that. So let's look at daylighting. Again, this is looking at things from a holistic standpoint for health and wellness. The other thing is we're beginning to see a consumer-driven rather than an industry-driven desire, which I think will help our industry, is people asking for buildings that provide healthy places to work, especially the millennials. They want well-lit buildings and buildings that are ventilated and buildings that aren't going to make them sick. So let's look at lighting and daylighting a little bit, okay? The impact, positive impacts of daylighting, both in commercial and educational buildings and residential spaces. It's been validated, it's consistent, and there's essentially a range of light that we go through every day. Starting out in the morning, it's more in the red and orange spectrum. In the middle of the day, we go to a blue spectrum, and then back again to an orange spectrum. And that creates these circadian rhythms in our bodies, right? And the orange releases melatonin, which helps us start winding down, helps our brain start getting ready to rest and recover, just like an athlete that's been and worked out and built up a lot of that lactic acid all day. Our brains need some rest at night, and when they're exposed to a lot of blue light and can't get that rest, then we become a little less, our brains function a little less. Okay, so we can't get those cycles to match our natural circadian rhythms. So what can it do? Exposure to blue wave light, it causes suppression of melatonin, it delays the timing of our circadian rhythms, it elevates our alertness, okay? So all the above things make it harder to fall asleep. So even if you've been at work and you've been in a really blue light type situation all day, it can still take longer to go to sleep. CBRE is a big portfolio manager of properties at some of the bigger commercial properties in the U.S. And they found that a 12% improvement on productivity tests for people in spaces with circadian light. With LEDs, they're able to tune them to different colors and tune them throughout the day to change those colors. So the lighting systems are becoming less expensive and also able to be adapted to different times of the day and work with people. So circadian lighting, again, every one of our cell phones probably today, and most of our screens can be put in a night or a day mode, so that at a certain time of day or whatever, it goes to a more reddish or orange light. It's probably built into the phones. These are simple things we can do to help ourselves. So yeah, just don't lay in bed at night staring at that blue screen before you try to go to sleep. And I think this is one that's really telling. Okay, lighting and sleep. Your evening exposure to bedside lamps and computer screens and how it can affect you and your alertness. All right, so this is kind of a 0.05 blood alcohol level here if we were comparing it to somebody that drank a lot of alcohol. And this is a legally impaired about a point, somewhere about a 0.75, 0.8. And then this is relative performance being, the higher up is worse. You saw the 1.04 versus a 1. And then time of day. So let me tell you what this compares to. So the graph is, 17 hours of sleep, or you go 17 hours a day. So, that leaves you 7 for sleep. Your cognitive functions are about right here at a 0.05% blood alcohol level. If you've gone 24 hours with sleep, which a lot of our truck drivers do, people with large masses heading down the road, and this is the time of day when there's the most frequent fatal truck accidents in the U.S. You're operating just as if you were legally drunk. Okay, so it's telling that just lack of sleep can have such an effect on not just your cognitive function from at a performance level. This is a performance level, but again, and this is a performance task and not a professional task or task like that. So lack of sleep can affect us in many ways. And there's easy ways to do things. Like I said, you can change these screens so you're not looking at your blue screens at night before you go to bed. It's recommended that you change out your bedside lights to these that produce a little more orange light. Some of the products there. So So I'll leave it at that. We'll move on. But the key is just changing the color of light you look at different parts of the day. So you stay in that natural rhythm of morning, midday, and night. So comfort and productivity. All right, so here's a study that was done. Again, the sources here for evolving opportunities for providing thermal comfort. Building Research and Information Center. They surveyed 351 buildings, 53,000 occupants, and then they found widespread discomfort with sound and noise, temperature, air quality, and showing the highest levels of dissatisfaction. So again, if you look at 0 is somewhat neutral and moving out this way, very satisfied. Most people were satisfied with the amount of light, the ease of interaction, comfort of their furnishings, and those things. But what they complained about were down here, and look at it, visual privacy, air quality, noise level. They're all getting either neutral or starting to be a negative impact on their satisfaction rates. And sound and noise being two of the big ones. Temperature, increasing office temperatures from 72 degrees to 87 degrees reduced performance by 10%. So again, a peak at about 72 degrees being a 1 on this rating scale, and then is raising the temperature. So again, looking at passive design and natural ventilation, figuring out how to adapt to where we don't go through that curve throughout the year when we have to deal with higher or lower temperatures. So again, another survey. Hospitals. Hospitals are a key thing. I mean, we see how many people go, and Bill, you were just talking about asthma patients with a number of visits, 500,000 a year. But some of the research there, complaints, noise complaints outnumber all others in the hospital too. All right. And here's some of the things they found. It disturbs the patient's rest. So again, if you got a patient that's not getting sleep, they're not recovering as fast. Increases their oxygen saturation, elevates their blood pressure. You can read the thing, but slows wound healing, amplifies exhaustion and burnout of the staff. Increases levels of rehospitalization. So significant impacts on hospital stays with the levels of noise. So again, just thinking about all the things we need to think about to create a healthy building. So those 9 foundations. A lot of variables there. And then let's just kind of look forward for a minute. I'm going to talk about one thing that's kind of going on in my small town, Charleston, South Carolina. We're part of a study, or I think the Rockefeller Institute is involved with some of these grants. It's called a Blue Zone Project. Okay? And so if we were to reduce risk factors for health and well-being, our city, which is about a city of about 500,000 people, they figure we $543 million in healthcare costs in 20 years to be saved. And here's a few more statistics from that. There's 42 communities that's participating in this. It's based on 9 different pillars. So, okay, we've got the 9 foundations. Got to talk about another standard that's gone to 10, I think, when I put in there. Charleston would be the first Blue Zone on the East Coast, so we are. And there's 1,685 participating organizations. The previous Blue Zones, the very first ones that went through, successfully lowered childhood obesity by 50%, so that was a big deal. And then it's estimated 2,250,000 lives have been impacted already by it. So we've become part of that group, and then actually did this presentation to that group not too long ago, so I've included these slides there for them. some of the consumer-led, like I said, mentioned that consumers, I think, are going to drive this, and that's good for us and our industry and the opportunities we see. A Healthier Hospitals initiative is pushing for safer chemical commitments from many of the large healthcare providers, including ours, which is Medical University of South Carolina. Google has developed a materials and construction program that rewards manufacturers who will provide transparency, at least say what chemicals are in those products, right? We got to figure out what's in them before we can start determining which ones are bad for us and which ones we need to eliminate. IKEA has made a commitment to reduce the use of toxic substances in their furniture, either limited code-related or full bans on bisphenols, bromated flame retardants, formaldehyde, and heavy metals. So people with cash and clout are beginning to drive the industry away from some of these chemicals we've talked about. How about building rating systems? Do you all use LEED here? The LEED rating system, some? Yeah? All right. All right, so we've got LEED V4, and actually they're rolling out LEED V4.1, I want to say in 2 weeks. They're already holding workshops on it. The Living Building Challenge, it's a fairly rigorous rating system. It's based on health and wellness for the most part, and whereas you've got levels on some of these, the Living Building Challenge is based on petals, so you earn petals, whereas that may be your number of credits. Green globes is the number of globes, and the Living Building Challenge is petals. And most of it's focused on health and wellness more than energy. Fitwell was created by the U.S. Army Corps of Engineers and then privatized. So it's probably one of the least expensive and just as rigorous systems to employ because there's free guidelines sitting out there for it. And then there's the well building standard that's come along. And that's a for-profit building rating system that has gone to, this is the one I said headed up the 9 to 10. So I think the one that we see that's different is Nourishment. That's added over the 9 that were listed before. But it's starting to come into our rating systems, and most of the rating systems are either incorporating it right into the rating system, or they're using one of these as an overlay for some of their credits, okay? So as building rating systems gain popularity, you will see more requirements for these health and wellness initiatives and goals to be built in or be required if you're going to comply with the rating system. So, building health services. So what can people like us do? What are some of our opportunities? Well, we're poised to get into and do air quality testing as we begin to learn science and get sensors that are reliable. To gather data, test that air and water quality, ventilation testing and balancing, building retro commissioning, inspecting equipment, material transparency specifications. So getting some of these labels on chemicals and material certifications, and then of course building certifications. Those are all opportunities for us as engineers to develop new products and services and extend the life and offer new skills and offer new services to our clients. So what should FASHRAE be doing? And I think you'll see some of the overlap there with what Bill had in one of his concluding slides, but collaborative research. And it's multidisciplinary now, and with the data that's coming in and the analysis, we need people in the psychological, physiological, and medical professions. GSA in the U.S. and our Centers for Disease Control are doing a lot of research on the effects of our environment and on productivity. And it's more bottom line driven. Well, what they're dying to have is somebody like an FASHRAE that can take that research and turn it into practical guidance for design professionals. So we need a way to do research, education, then application, and then start all over again on that triangle. We've got committees. Bill was talking yesterday that he is, what is your position on the Environmental Health Committee?
Just incoming member.
You're an incoming member. So Bill is a member of the Environmental Health Committee. He's done lifelong research and devoted his career to indoor air quality and ventilation and these things. And he's a member of that. We just stood up last June the Multidisciplinary Task Force on Health and Wellness. Bill and I both are members of that task group, as well as many of the TCs and FASHRAE, but also people like Harvard, people like GSA, people like CDC, people are creating some of this research. That will lead to standards and guidelines, either updating existing ones like 62 and 55, our thermal comfort, our ventilation standards, also best practices. That's what we need. And we need it based on sound research and good science. There's a paper that was published a few years ago by Andrew Pursley, where he looked at from the genesis of the first day of FASHRAE 62.1 and where all of our ventilation rates had come from. And I think we just need more science to hone in on why and where and why we put different ventilation rates in different places. And that supports it. Training. Our engineers, our contractors, and our owners, all of us, we all need training. We're going to operate a building and operate it at high performance, but also where high performance doesn't mean just energy efficiency, but performance of the people working in the building keeps us healthy and productive. Certifications, both of buildings, but also of designers, contractors, installers, operators. And then advocacy. We've got to be willing to advocate to our regulators and our government officials to work with more current codes and standards and regulations. And help our, just like FASHRAE, we're a voluntary standard development organization. So we want to be proactive and develop these standards before some government agency tells us we have to, right? By doing the right thing. So kind of what came from Joe Allen out of this study was that we're all healthcare providers, right? Everything we do in some way or another affects our health. And so before I give the last slide, I want to give you a hypothetical situation. So say you walk into your office and you're not necessarily in the best of moods. And immediately you've got security cameras that have caught you from the time you got out of your car and you're walking in, and it's already looking at your facial expressions, and believe it or not, this little muscle right here between your two eyes can tell a lot about your mood, and very subtle dimensions of how close and far away your eyes move, but it's already determined that you're not in the best of mood. Okay, so you walk in the door, and as you're on your way to your desk and the company wants you to be as productive as you possibly can, it throws a little red hue on the lighting as you're walking down the hall. Ventilation system immediately takes action, bumps the ventilation up just a tad. It also throws a little lavender in for some, a little aromatherapy, because lavender has been shown to improve a person's mood, and then it adjusts the temperature and humidity down just a hair. Sound far-fetched or sound outside the capability of technology today, anybody? That's actually a pilot project that's already going on at a couple of universities in the U.S. right now, a couple of architects, and that's they're studying whether they can make a smart building, smart home, smart conference room. They can sense in a conference room that, hey, the discussions have gone to a lull, and one of the parties has got a motivation for it to either stay that way, or one's got a motivation to jack the conversations up a little, depending on what's been programmed into the algorithm. It can start manipulating the people's behavior in those conference rooms. Might be a little scary, but that's where we're at, and it's not too far away. With that, that's my story, and just like Bill, open it up some questions and answers, or we can talk at the end of the day.